Hello everyone, once again welcome to our physics class. So we had covered our physics portions for CBSE class 12 examination. Today we will go for a sample question paper discussion. As you all know, CBSE has released sample question paper in new pattern. So let's be familiar with the new pattern. On the screen, you can see the first question. It's a 1-mark question. Name the physical quantity having unit Joule per Tesla. So which physical quantity has the unit Joule per Tesla? Children, for your convenience, I have uploaded sample question paper in my notes section. So please upload the sample question paper and go through the slides. Okay. So name the physical quantity having unit Joule per Tesla. So which is physical quantity has unit Joule per Tesla. It is magnetic moment. You had already studied one more unit for magnetic moment, that is ampere meter square. So one more unit is there for magnetic moment small m, that is Joule per Tesla. Okay. Next is mention one use of part of electromagnetic spectrum to which a wavelength of 21 centimeter belongs. So I have already mentioned the different types of electromagnetic waves. There are 7 types of electromagnetic waves and the wavelength of each waves must be noted. I told you to study the wavelength of each of the electromagnetic waves. So whenever you go through the spectrum, you can identify the electromagnetic wave whose wavelength belongs to 21 centimeter is microwave. Okay, microwave. The wavelength of microwave is 21 centimeter, nearly 21 centimeter. Give the ratio of velocity of two light waves of wavelength 4000 Armstrong and 8000 Armstrong traveling in vacuum. So you are supposed to find out the ratio of velocity of two light waves of wavelength 4000 Armstrong and 8000 Armstrong. Here children, this is a very tricky question and at the same time very easy question. See, you are supposed to find out the ratio of velocity of two light waves having wavelength 4000 and 8000 Armstrong traveling in vacuum. This vacuum is very important. Light waves are traveling in vacuum, and if light wave is traveling in vacuum, its velocity is 3 into 10 raised to 8 meter per second. Whatever be the electromagnetic wave, any electromagnetic wave in vacuum travels with the same velocity, that is 3 into 10 raised to 8 meter per second. So here the velocity of the first wave will be c, velocity of the second wave also will be c. So c by c will be 1, hence ratio will be 1:1. Okay, and here in the first part of this question, that means in the OR part, I forgot to mention one thing. In the question they have also asked one use of that electromagnetic wave. So we have identified the wave, which is that wave microwave, belongs to the electromagnetic spectrum whose wavelength is 21 centimeters. So it's a microwave. And what is the use of microwave? And microwave can be used in radar, and microwave is also used in microwave oven. Okay, so that is the use. You can mention any one use of that. Then let's go to the next question. An electron with a charge -e and mass m travels at a speed v in a plane perpendicular to a magnetic field of magnitude b. The electron follows a circular path of radius capital R. In a time small t, the electron travels halfway around the circle. What is the amount of work done by the magnetic field? This is also a tricky question. Whatever data are mentioned here, all are unnecessary actually. Here, what is the amount of work done by the magnetic field? See, what is the amount of work done? I will say work done by the magnetic field is 0. Why? Listen here. When do the charged particle follows a circular path? Whenever the particle enters perpendicular to the magnetic field. So if this is the magnetic field B, and whenever the particle enters or moves like this, enters into this magnetic field like this, Okay, this is the magnetic field, and whenever the particle enters like this into this magnetic field. The velocity of the particle will be v, and here the particle enters by making an angle 90 degree with the magnetic field. In such situation, the particle will follow a circular path. We had already discussed this concept in our magnetism chapter. So, whenever the particle follows a circular path, what will be the force of this particle, or in which direction does the force point? So here the force of the particle is perpendicular. Okay, that means like this, upwards, and displacement of that particle is like this, right? So here the force and displacement is perpendicular to each other because the particle is executing a circular path. So here the particle gets displaced along this direction. That means the force is acting where, in which direction is the particle displaced, the force will also act along the same direction. So the particle was entering like this, the particle enters into the field like this and experiencing a force in the upward direction, it moved like this, hence it followed a circular path. So force is acting along upward direction and the particle displaces along in the perpendicular direction. Okay, so the force and displacement are perpendicular to each other, and whenever force and displacement are perpendicular to each other, work done will be 0. Okay, because force work done is equal to F dot D, that is F D cos theta, and if theta is 90 degree, then F D cos 90 will be F D cos 90 is 0. So work done will be 0. Okay, so that's about the third question. Let's move on to the fourth question now. Now what is the fourth question? A solenoid with n loops of wire tightly wrapped around an iron core is carrying an electric current I. If the current through the solenoid is reduced to half, then what change would you expect in the inductance of the solenoid? See children, the inductance of the solenoid does not depend upon all these things. Inductance of the solenoid remains the same. Okay, so that is the answer for that question. Inductance of the solenoid remains the same even if the current through the solenoid is reduced to half. Now, what is the OR question? An alternating current from a source is given by I is equal to 10 sin 314t. What is the effective value of current and frequency of source? So, the sine or AC current is given. What is the AC current? I is equal to 10 sin 314t. Okay, you know what is the general form of AC current? It is I equal to Im sin omega t. So instead of Im we have 10, instead of omega we have 314. Now you are supposed to find out the effective value of current. Effective value of current. What is meant by effective value of current? Effective value of current is IRMS. So how will you find out IRMS? IRMS is the effective value of current, and IRMS is equal to Im by root 2. And you know what is Im? From when you compare these two expressions, Im is equal to 10. So 10 by root 2. Okay, and 1 by root 2 is 0.707. So 10 by root 2 will be 10 into 0.707. So 10 into 0.707 will be equal to 7.07. 7.07, this much ampere. So this is the effective value of current. Next, we can find out the frequency of the source. So how will you find out the frequency? Here from the expression, when you compare these two expressions, you will get omega. What is omega? Omega is equal to 314, and you know omega is related to frequency using this equation. Omega is equal to 2 pi nu, where nu is the frequency. So 2 pi nu is equal to 314. Therefore nu is equal to, that is frequency, that is nu, equal to 2 pi. 2 is 3. Pi is 3.14. So 2 into 3.14. And here when you remove the decimal, you will get nu is equal to 314 by 2 into 3.14 into 100. It will be 314. So here also multiply with 100. So we'll get this value, and 314 into 100 is 31,400. So you will get 100 in the numerator, and when you cancel 2 with 100 you will get 50. So your frequency is 50 Hertz. Okay, frequency is 50 Hertz. Now we can move on to the next question, that is fifth question. What is the value of angular momentum of electron in the second orbit of Bohr's model of hydrogen atom? Okay, so let me rub this, afterwards I will discuss that. Okay, so what is the value of angular momentum of electron in the second orbit of Bohr's model of hydrogen atom? So the value of angular momentum, you know, angular momentum expression as per Bohr postulate is nh by 2 pi, where n indicates the orbit. So here it is asked in the second orbit, so n will be equal to 2. And when you substitute n is equal to 2, you will get angular momentum L is equal to h by pi. Okay, h by pi. So what is the angular momentum? It is h by pi. Now we can move on to the next question. That is sixth one. In a photoelectric experiment, the potential required to stop the ejection of electrons from the cathode is 4 volt. What is the value of maximum kinetic energy of emitted photoelectrons? So you had already studied one expression, maximum kinetic energy, K max is equal to E into V naught, where V naught is the stopping potential. So E is the electronic charge, that is 1.6, it is a constant value, 1.6 into 10 raised to minus 19 into V naught. V naught is the stopping potential, and you know, stopping potential is the potential required to stop the ejection of electrons, and it is given in the question, that is 4 volt. So this into 4, so whenever you multiply you will get an answer, and I think it is 64 joule. So this is the answer in joule. And if you want to find out the answer in electron volt, it's very easy. So what is the potential given? It is 4 volt, and in electron volt the maximum kinetic energy will be 4 electron volt. So just you need to multiply it with E. No need to substitute the value for E. Then you will get the answer in electron volt. Okay, so in electron volt the answer will be 4 electron volt, and in joule it will be 64 joule. Now let's move on to the next question, that is the seventh one. And so I am not discussing the seventh question here because it has been deleted from our syllabus. I don't know why they have included this question in our sample paper. Now next we can discuss the eighth one. How does the width of a depletion region of a PN junction vary if doping concentration is increased? And we had already discussed that. If the doping concentration is increased, the width of the PN junction, width of the depletion region will decrease, and hence conduction increases. Okay. Now what is the next question? It's not clear, but I know the question, so I will discuss that. In half-wave rectification, what is the output frequency if the input frequency is 25 Hertz? Okay, so whenever you go through the sample question paper, you can understand that in half-wave rectification, what is the output frequency if input frequency is 25 Hertz? So here input frequency is 25 Hertz, and in the case of half-wave rectifier, input frequency and output frequency will be equal. Okay, so here input frequency is 25 Hertz, so output frequency also will be equal to 25 Hertz. But if it is a full wave rectifier, if input frequency is 25 Hertz, then output frequency will be 2 times of input frequency, that is 2 into 25, that is equal to 50 Hertz. This is for full wave rectifier, okay, and for half wave rectifier it will be the same, that is 25 Hertz. So this is the answer. Now we can discuss the ninth question. When a voltage drop across a PN junction diode is increased from 0.70 volts to 0.71 volt, what is the change in diode current? The change in diode current is 10 milliampere. So what is the dynamic resistance of the diode? So dynamic resistance is given by the equation. Dynamic resistance RD is delta V by delta I, change in voltage by change in current. Okay, so what is the change in voltage here? Here the voltage is increased from 0.70 volt to 0.71 volt. So the change in voltage is 0.71 minus 0.70. Okay, divided by delta I. The change in diode current is 10 milliampere, and 10 milliampere you can convert to ampere. So 10 into 10 raised to minus 3 is 10 milliampere. And whenever you simplify, you will get the value as 1. So the value of dynamic resistance is 1 ohm. Okay, now let's move on to the 10th question. Before that, let me rub all these things from the screen. So what is the 10th question? Which specially fabricated PN junction diode is used for detecting light intensity? So which diode detects light intensity? It is photodiode. Okay. Now we can go through the assertion and reason type questions. So this is the new format that have been introduced. Assertion and reason type questions were not there for your board exams, but I think it will be there for your competitive examinations like a NEET, JEE, etc. So listen here. You know assertion and reason type questions because you had already gone through such questions in your class 10 physics board exams, right? So here both A and R are true. That means there are 4 possibilities for such type of questions. Sometimes assertion and reason can be true, but reason will not be the correct explanation of assertion. In other cases, both assertion and reason are true, but reason is not the correct explanation of A. And in some cases, assertion is true but reason is false. In some other cases, assertion is false and reason is also false. So you need to choose which of the 4 alternatives or which of the 4th option will be the best for the given statement of assertion and reason. Okay, so let's move on to the 11th one. In a non-uniform, what is the assertion part? Assertion part is in a non-uniform electric field, a dipole will have a dipole will have a translatory as well as rotatory motion. You know, it's true. If it is non-uniform electric field, dipole will execute both translatory and rotatory motion. And what is the reason here? In a non-uniform electric field, a dipole experiences a force as well as a torque. So if you want to know that the given assertion is the correct or given reason is the correct explanation of assertion, you need to join because in between assertion and reason. And if you join that word because in between this assertion and reason, and if you find that statement as a meaningful one, then you can be very sure that it will be the first option. Assertion and reason are true. At the same time, reason is the correct explanation of assertion. Okay, so here in a non-uniform electric field, a dipole will experience translatory as well as rotatory motion because in a non-uniform electric field, a dipole experiences a force as well as a torque. It is true. Because of the force and the torque, the dipole experiences a translatory and rotatory motion. So A will be the best possibility for this statement. So the correct answer for this is, correct option for this is A. Both assertion and reason are true, and reason is the correct explanation of assertion. Now we can move on to the next question. Question number 12. Assertion is electric field is always normal to the equipotential surfaces and along the direction of decreasing order of potential. Okay, that is the first assertion. Then reason. What is the reason part? Negative gradient of electric potential is electric field. See, what is the assertion? Electric field is always normal to equipotential surface. That is true. And it is also acting along the direction of decreasing order of potential. That is also true. So, assertion statement is true. Reason, negative gradient of electric potential is electric field. So, whenever you consider the reason statement alone, it is also true. But there is no connection between assertion and reason. Reason is not the correct explanation of assertion. Why? Because the electric field is normal to the equipotential surface and it also acts along the direction of decreasing order of potential, but it is not because of the fact that negative gradient of electric potential is electric field. So we cannot join a word because in between them, because the reason is not the correct explanation for assertion. So the correct option for this is B, because individually assertion and reason statements are true, but R is not the correct explanation of A. Reason is not the correct explanation for assertion. Okay. Now we can move on to the 13th question. A convex mirror cannot form real image. Yeah, it's true. But what is the reason? Reason, convex mirror converges the parallel rays that are incident on it. Is it true? Can a convex mirror converge anything? No, because convex mirror is a diverging mirror. So it cannot converge any rays falling on it. So assertion is true, but reason is false. So which option is that? A, B or C here? Among this, C. Assertion is true, but reason is false. So here the correct option is C. Now, let's move on to the next question, 14th one. What is the assertion? A convex lens of focal length 30 cm cannot be used as a simple microscope in normal setting. Okay, and what is the reason? For normal setting, the angular magnification of simple microscope is M is equal to D by F. Okay, so a convex lens of focal length 30 cm cannot be used as a simple microscope in normal setting. Yeah, it is true. Okay. And what is the reason? Is it the reason for that for normal setting the angular magnification of simple microscope is D by F? Reason is not the correct explanation of A. Both are independently, both are true statements, but reason is not the correct explanation of assertion. So here B is the correct option. Okay. So like this we need to solve the assertion and reason type questions. Another type question is case study based question. So let's go through that. A Faraday cage or Faraday shield is an enclosure made of a conducting material. The field within a conductor cancel out with any external fields. So the electric field within the enclosure is 0. These Faraday cages act as a big hollow conductors, and you can put things into the shield them from electric fields. Any electrical shocks the cage receives pass harmlessly around the outside of the cage. So this is the case. Based on this case, so many questions are given. Nearly 4 or 5 questions are given below, and you need to answer the questions based on this case. So let's move on to the first question. Which of the following material can be used to make a Faraday cage? So which of the following material can be used to make a Faraday cage? See, what is the first sentence? A Faraday cage is an enclosure made of a conducting material. Okay, so it must be a conductor. So from the option, given option, which is the conductor? Only copper is the conducting material. So copper is the correct answer. Okay. Now what is the second question? Example of a real world Faraday cage. It's a car, because it is always advised to stay inside the car during lightning, because in case if there is a possibility of electric shocks, then it will pass harmlessly around the outside of that car. Okay, so car is a real world Faraday cage. Then what is the third question? What is the electrical force inside a Faraday cage when it is struck by lightning? So when it is struck by lightning, what is the electrical force inside the Faraday cage? See, just look at the second line here. the fields within a conductor cancel out with any external field. So the electric field within the enclosure is 0. So the electrical force inside the Faraday cage is 0. So option C is the correct answer, 0. Then what is the fourth question? An isolated point charge plus Q is placed inside the Faraday cage. Its surface must have charge equal to. So a plus Q charge is placed inside the Faraday cage, and on the surface there is a charge. And what should be the charge? See, the charges inside the Faraday cage cancel with the charges outside the or on the surface of the cage, and thus the electric field becomes 0. So if plus Q resides inside the cage, minus Q should reside on the surface of the cage, then only the total field will be 0. Plus Q minus Q will be 0. So the option C, minus Q, is the right answer. Okay, so this is the case study based question. Then another type of case study based question is the sparking brilliance of diamond. Okay, that is the case. The total internal reflection of light is used in polishing diamonds to create a sparking brilliance. By polishing the diamond with specific cuts, it is adjusted the most of the light rays approaching the surface are incident with an angle of incidence more than the critical angle, because a total internal reflection take place inside the diamond, multiple total internal reflection. So for that, light must be incident at an angle greater than the critical angle, then only the total internal reflection can occur here. Hence, they suffer multiple reflections and ultimately come out of diamond from the top. This gives the diamond a sparking brilliance. So this is the reason for the sparking brilliance of diamond. So based on this case or this concept, many questions are there. Let's go through the questions. What is the first one? Light cannot easily escape a diamond without multiple internal reflections. This is because its critical angle with reference to air is too large. Its critical angle with reference to air is too small. The diamond is transparent. Rays always enter at an angle greater than the critical angle. So which is the correct answer? Light cannot easily escape a diamond without multiple internal reflection. So B, its critical angle with reference to air is too small. Okay, that's why multiple reflections are possible there. Now the critical angle for a diamond is 24.4 degree. Then its refractive index is. Okay, so there is a relationship between the refractive index and the critical angle. Mu is equal to 1 by sin IC, or sin IC equal to 1 by mu. Okay, so from that relation you can easily find out the refractive index. So mu equal to 1 by sin IC. Okay, so 1 by sin 24.4 degrees. So you need to take a logarithmic table, a log table, in order to find out the value of sin 24.4 degrees. So all of you must buy a Clark's table. It will be very useful for you to find out the answer of such type questions. And here the answer is the A. That means first one, 2.42 is the answer. Now let's move on to the third question. The basic reason for the extraordinary sparkle or sparkle of suitably cut diamond is that it has low refractive index, it has high transparency, it has high refractive index, it is very hard. Answer is it has high refractive index. Okay, let's move on to the next question. A diamond is immersed in a liquid with a refractive index greater than water, then the critical angle for total internal reflection. So the options, two more options are left that I will tell you. So the first option is will depend on the nature of the liquid. Second option is decrease. Third option is remains the same. And the fourth option, that means D, is increase. So whenever a diamond is immersed in a liquid which has a refractive index greater than water, then what is the critical angle for total internal reflection? Critical angle of total internal reflection will also increase, because the liquid has a density greater than that of water. So the critical angle for the total internal reflection also will increase. Okay, so fourth option, that means option number D, increase, is the correct answer for this. Now see the fifth question. The brilliance of diamond in the second diamond will be, it's very clear, less than the first one. Why? Because in the first diamond, multiple total internal reflection occurs. Due to that, sparkling effect is observed, or that brilliance of diamond is the actual reason for the brilliance of diamond is the multiple total internal reflection, and it is more in the first diamond. In the second diamond, we cannot see such type of reflection. So the brilliance of the second diamond will be always less than the first. So option A is the correct answer. Okay, and section C and section D are left, and we will discuss that questions during the revision time. Okay children, so with this I am concluding my session. Notes of the topic. Notes means the sample question paper have been uploaded. So just download the question paper and keep it with you. It will be very helpful during our revision sessions. Okay children. And besides that, I will also release some study materials prior to your revision. So please download your revision materials. That means your study materials, and keep it with you. And I will discuss the answers of that questions given in the study materials during the revision time. Okay, so all of you stay safe, stay home, keep learning. Thank you.